We said so far that alkanes are extracted by fractional distillation of crude oil. So alkanes, they're simple hydrocarbons. So how are these how are alkanes related to their uses? Well, alkanes, and actually alkenes too, and alcohols as well, but actually all of organic molecules, they release energy when they're combusted. So the main chemical property, the main reaction that you need to know about alkanes is combustion. Combustion reaction. Combustion means reacting with oxygen. So there are some tricks in how to write the equation and balance it, because that's really the challenging part. So let's say we have a C4H10 reacts with oxygen. Combustion can be complete or incomplete. Complete, it forms carbon dioxide and water. Incomplete, it could form carbon or carbon monoxide or a mixture of both, and then water escapes. So complete, or better, incomplete, occurs because there is a lack of oxygen. That's why it could occur when there is a fault in an engine, or like in the heater of the houses. Okay, if there is not a good flow of oxygen, incomplete combustion could occur. So let's write the products of this. Let's say this is a complete combustion. The products will be carbon dioxide and water. Of course, this reaction has to be balanced. There are big numbers here, so I would suggest you to start always from the easiest one. Carbon, 4 carbons on the left-hand side, only 1 on the right-hand side. We're going to add a 4 here. Hydrogen is the second easier one. Don't worry too much about the oxygen, because as you can see, is on different compounds on the right-hand side, so it makes it a lot more difficult. So hydrogen, we have 10 on the left-hand side and just 2 here. Well, we're going to balance it with a 5. And now we can think about the oxygens. So we have 2 oxygen on the left-hand side. And how many do we have on the right in total? Well, we have 8 oxygens because we have 4 times by 2. And then we have 5 from the water. 13 in total. We can use half numbers to balance it, just because otherwise we would have very big multiples. So how do we make 2 into 13? We times it by 6.5. So this is how we balance a combustion reaction. Carbon first, then hydrogen, then oxygen. Let's compare it with the balancing of an incomplete combustion. Let's say now the product is only carbon monoxide and water. Same way. First carbon, we have 4. Then hydrogen, we have 5. But now, how many oxygens do we have in total? 4 on the right-hand side, 5 plus 5, 9, and just 2 on the left-hand side. How do we balance it? We put a 4.5 on the left-hand side. So as you can see, less oxygens present when we have the incomplete combustion. And one more thing that is very interesting about incomplete combustion is that this is very toxic. Actually, this too. Well, carbon, it's normally present in the solid form. So if you see buildings that they get dark, is because of this particulate of carbon that actually deposit in the atmosphere. So it's actually a solid. So you can imagine why it can be bad for your health. Yeah, solid particles in the lungs. Yeah, could obstruct the airways. Carbon monoxide, though, is toxic for different reasons, and it's because it binds to hemoglobin. Hemoglobin is the protein that carries oxygen in our blood, but carbon monoxide binds with it more strongly than oxygen. which means that if there is carbon monoxide in the atmosphere, we breathe it in, we will have less oxygen circulating in our body. And you can think about why less oxygen is bad. Well, it would lead to suffocation, less respiration. And then you can look at the biology to understand better the consequences of this. Okay? This is the main reaction of alkanes, and we will practice later on some more reactions with alkenes and alcohols with a similar balancing. But we will look now at alkenes and alcohol and carboxylic acid that have a bit of a broader chemistry because, well, they have a functional group that makes the molecule more reactive.